curve. So remember, as we take a look at our normal curve, let's label our number line at the bottom here. What goes in the middle of our normal curve? Our median, mean, and mode, all of them. So we use that X bar. We learned that last Friday. X bar, which also stands for mean. Then as we work our way out, we're moving those distances. So remember, what do we call those distances as we move our way out? S. We labeled it SD, like this is a +1 SD. SD stands for standard deviation. Yep. So we're talking about how far things move from the mean. So we have our +1 standard deviation, and then +2 standard deviations, +3 standard deviation, as I go to the right, we're adding on, but as we go to the left, we are subtracting. So -1 standard deviation, -2 standard deviation, -3 standard deviation. So the reason why we have these standard deviations is because it breaks up our data into these intervals where most of our data is organized, where we're able to say this is where the majority are. Okay, again, this is going to be a really important part of your notes, really important part for your test. You're going to want to make sure you have these numbers written down if you're planning on passing your last test. All right, in our first amount here, remember this is like a histogram. So if we think about these bars going up, 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 we might have a couple bars here. But in this first one, we have 34% of our data. Mr. Kwan? Oh. Thanks, sorry, I didn't know who it was for. We have 34% of our data in this first section. And since it's symmetrical, symmetrical means it matches what's going to be in our side opposite of the mean, 34%. So I'm going to color those ones green. So find one color that you'd like there for the middle. Doesn't have to be green, it can be any other color. Freya, do your math here, bro. Do you need a pencil? Okay, let's go, man. It's not going to be a lot of time to do this later. I know you usually do a really good job of getting caught up, but... Alright, so as we take a look at that, that's this first interval. This first kind of top part here is kind of grouping it together. So if we look within one standard deviation, we're looking to the left one and to the right one. We're grouping them together on either side. What is 34 and 34 together? 68. So in this first part, we have 68%. That is within one standard deviation. Abdirman, why don't you go back to your seat? Okay, so in that first amount there, we have 34 and 34, so together that makes 68. So 68% of our data is within one standard deviation. Which means if I randomly pick a data point, is that unlikely, even chance, likely, or certain? Likely. It's above 50%, it's likely it's at 68%. And that's what we labeled yesterday, or not yesterday, but Friday. We said if a data point is randomly chosen, it's likely to be in one standard deviation. And that's where our likely comes from. 68% of our data is in that first standard deviation. All right, then we're going to add on. And our next standard deviation within that, in between the +1 and +2, is 13.5%. And because it is symmetrical, if this side is 13.5, other side is 13.5. Then grab another color there, color that in. I'm going with blue, I guess. Using colors on this will be nice and helpful. What? Oh, you can't hear me? I'm listening to music that loud. Why don't you take the earbuds out? So using colors is going to be helpful on this one to really show how things are working together. All right, now if I talk about the data within two standard deviations, that means it could be 2 to the right or it could be 2 to the left. I'm going to add up all 4 of these. Are these numbers going to be bigger than 68 or less than 68 when I add them together? Yeah, more than 68. Why? Yeah, because it's 34 and 34 is 68, and we're adding on past that. So I'm doing 13.5 plus 34 plus 34 plus 13.5. And we get 95. So in this next part up here, if you want to color code it with that. Okay, that represents that 95% of our data. And that 95% of the data is within 2 standard deviations. So it could be 2 standard deviations to the left or 2 standard deviations to the right, but we're within 2 standard deviations. All right, as we work our way out further and further, our data is getting less and less. It's going down. So we start with 34%, then 13.5%. Our next one is going to be 2.35. And again, it's symmetrical, so on this side and on this side. We're going to use that last color for this part. Alright, so I could re-add all of these again, or we know in the middle we had 95%, so I can just take 95% and add on, how much on this side? 2.35, and add on 2.35, and we get 99.7. Okay, so as we go to the top here, this one that goes all the way across almost, not quite all the way across, that is our 99.7. That is within 3 standard deviations. Exactly. So when we looked at this Friday, we said that it was likely to be in 1 standard deviation. 68% likely? Yeah. It said most likely to be in 2 standard deviations. Is 95% most of our data? Yep, it's most. And then it said almost certain to be 3 standard deviations. What would be certain? What percent? 100%. And do we have 100%? No, almost. Not quite. 99.7. So for our last little parts here on each end, when we look at it, how much should be all of our data? 100%. So we know we have 99.7. So if I take 100 minus 99.7, how much data am I left with? I'm left with overall 0.3, but then we have to break it up into 2 parts. So 0.3 divided by 2, I'd have 0.15 on both sides. Okay, so in our last little part here, if we can try and write this a little bit smaller, we have 0.15%. Yep, 0.15% to make up that last 100%. Now this 0.15% though, it's not necessarily between the 3rd standard deviation and the 4th standard deviation. Notice how we didn't put 4 there? That's just somewhere beyond our standard deviations. Okay, so it could be like way down the road, it could be something that's a really big outlier, or it could be way in front, somewhere beyond these 3 standard deviations. It's not necessarily right after them. It could be really far away. All right, why do you think this is called the 68, 95, 99.7 rule? Whoa. 68, 95, 99.7. And that is always the case when we find our standard deviation with a normal curve, or as close to that as possible. It's what we can guarantee. All right, you're going to get one more glue in today. It's the same glue in we actually got last week, but you're going to glue it in on the next page. So I'm going to glue this one on the next page. Yep. That would be the next page. All right, we're going to do 2 examples here. So go ahead and get this glued in on the next page. Remember, be careful with our glue sticks. If you drop a cap, please pick it back up. Please make sure the caps actually get onto the glue sticks. We're running really low on glue sticks. We just have a couple more days that we need to use them, so please make sure you get them back on. What? What am I doing this summer? I have my dive camps at St. Ben's and St. John's. I coach. What are you doing this summer? Don't know. Live each day, have an own adventure. One adventure each day. Sounds about right. Alright, so as we take a look at this first one, it has no labels, we just have our normal curve. So we're going to practice doing that labeling, which is what we did on Friday. So we have our lifespan of batteries. Lifespan of batteries that we're going to talk about. So generally speaking, when you go buy a battery from the store, like a AA or AAA battery, it should last a certain amount of time, right? Okay, if I put new batteries in my remote, I would expect, if I have two batteries in my remote, I would expect both batteries to pretty much run out at the same time, right? Okay, is that the case though? Do all batteries, are they going to all have the same exact lifespan? No, what are some factors that could change the lifespan of a battery? The brand, size, what you're using it for. Some you have higher wattage than others. Or just depending on how well you take care of it. If you store your batteries in the sunlight, or you store your batteries in a freezer, I don't know. Probably one of those isn't going to work out well. Alright, so we're going to say that the mean, this company that did this, the mean is 721 days. Talking about maybe some lithium batteries here, the ones that last a long time. 721 days is our mean. And we're going to say our standard deviation is 105 days. Alright, so first thing we're going to do is we're going to label our number line here. And then we're going to ask ourselves a question after we get this all labeled. So, where do I start in my normal curve? Good, the mean, we have 721 days. That's going to go in the middle, 721. Yep. As I go to the right, we're going to add on 105. So I'm just going to use my calculator for that. So 721 plus 105, 826. Okay, we're going to the next line, so I'm going to add on 105 again. 931. And then add on 105 one more time. We get 1,036. Give you a second to copy that down. All right, as we work our way to the left, we're going to subtract 105, yep. So again, I'm going to just take out my calculator. I'm going to start with 721 minus 105. We get 616. Minus 105 again, 511, and then minus 105 one last time, 406. All right, a question that we're going to answer in this one is what percent of batteries last 511 to 931 days? What percent of batteries last 511 to 931 days? So as I'm looking at that 511 to 931 days, I see 511 is here, and I'm going all the way over to that 931 days. So if you want to kind of show how that goes. So is that within 1 standard deviation, 2 standard deviations, or 3 standard deviations? We're going out 1, 2. So 2 standard deviations. Okay, if you want to color code it, you can, using those same colors you used in the first page. We have that first standard deviation in the middle. And then we're adding on 1 more on each side. So using our rule, or if you need to flip back to look, that 2 standard deviations, what percent of our data is within 2 standard deviations? Yep, 95%. Our rule is 68, 95, 99.7. All right, if you flip back, some of you have it back to back, which is nice. That 2 standard deviations is 95%. Okay, so that 2 standard deviations, 95%. All right, we're going to do one more. Last one, we're going to talk about our ACT scores. ACT is a standardized test that you usually take to get into college. Some colleges have it as optional now to get into. You don't have to take it. Some colleges are bringing it back. COVID kind of screwed up ACT testing, so that's why they made it optional for a while, and now some colleges are realizing we don't really need it. Some colleges are saying, we need that back. Okay, so ACT, it tests you on science, math, reading, writing, and writing, I don't know, grammar, right? Something, I don't know how. No, that's it. That's access. You didn't take the ACT? I took it 3 times. My best time was the second time. All right, so we're going to say, the mean is 21. So if you get a 21 on your ACT, you're looking at getting some scholarships to a state college. So at St. Cloud State, Minnesota State University, NDSU.
Because they see how good you did?
Yep. And 21 is a decent score. Perfect score is a 36. No. It is 6. You have there's 4 sections, and in most sections it's 60 questions for 60 minutes. So. All right, our standard deviation is 4. So based on that information, I'm going to give you a second here. You should be able to fill out this bottom part here. So if you want to try and fill out lightly, you should be able to fill out your number line based on that information. Right? Perfect score is 36? Now I'm questioning myself. Yeah, 36. Both my cousins got a 36. brother and sister. Insane. Super smart. So there's the ACT and the SAT. ACT is kind of more Midwestern. It's in this like central part of America that we use the ACT. If you're looking out to go west or east, you would take your SAT, which is out of 1600, is a perfect score. If you need me. All right, so we're going to start in that middle. We have 21. And as we work our way to the right, we're going to add how much? 4. Good. And then as we go to our left, we're going to subtract 4. So 21 plus 4, 25, plus 4, 29, plus 4, 33. Nice work. And on our way to the left, 17, 13, and 9. All right, so as we work our way through this, the big difference between ACT and SAT. SAT, you get penalized for guessing. So if you guess and you get the question wrong, you actually get negative points. The ACT, if you guess and you get something wrong, you just get no points for it. Just if you got it right or wrong. If you got you get a positive for getting it right, but then if you get it wrong, depending on how wrong you get negatives. So it's better to leave an answer blank on the SAT, because if you leave it blank, you don't get any positive or negatives. You get 0. So you only want to answer the questions if you know them on the SAT. On the ACT, then you get negatives. I don't know. I've never taken the SAT. I don't know. It freaks me out. You took it? Yeah. The ACT to me was a lot less. ACT felt more like a normal test to me. SAT was like, oh. Yeah. All right. Last question here is, what interval contains 99.7% of the data? If you're planning on going to like an Ivy League school like Harvard, Yale, Dartmouth, you need to take the SAT. If you're planning on just going to any college, I would take the ACT, and then you can decide if you want to use it or not. Just because you take it doesn't mean you have to put it on your college app unless they require it.
I took the SAT. I didn't even use it to come to St. Paul State.
You didn't use it? No.
It was like 800. So
Yeah.
So you didn't even do good?
I didn't do that good.
No. But if you do good, then you can get scholarships based on that.
Just why?
All right, so if I go 99.7%, is that by 1 standard deviation away, 2 standard deviations, or 3 standard deviations? Yeah, if we look back, 99.7 is the 3 standard deviations. So I want to go 3 away from my mean. So as we go 3 away to the left, it would start at 9. So somewhere between 9 and 33 would be our scores. That would have 99% of that data. Pretty sure you get a 9 on the ACT just for filling out your correct information, making sure your name is on there, your address, things like that.
Points for that?
The lowest I've seen on an ACT is 9. Most people don't score below 9. If you can't get negatives on the ACT. Can't get negatives on the ACT. Most people, usually if you're in the 30s, that means you could go to a private college and get scholarships. If you get 36, you are going lots of places. Colleges will contact you to ask you to go to their school. As I was told in high school when I went to the college fair, you do not contact Harvard. Harvard will contact you.
If they want to have you there?
What? They did not contact me. I was not that good. I did go and I wanted to get a brochure, and they're like,
You wanted to go to Harvard?
No, I just wanted to go like at the, so they had a college fair with like all the colleges, right? And then